Assalamu alaikum wa rahmatullah. Hello, everybody. Our class of today is all about the virtual LAN routing. So in the last class, we have taught about the virtual LANs and the configuration of them and so on. So before we start the virtual LAN routing, I'm going to return back to the last class slides. So this one is the virtual LAN principles. So in the last class, we have taken the LAN limitation, and we said that no broadcast domain to manage expanding local network. So that means if the network is expanded, becomes large, then having a large network with the only one broadcast domain that will negatively affect the performance of the network. That's why the big domain or the large domain have to be broken into small domains. So how to make that? How to make small domains? All by implementing the virtual LANs. So every virtual LAN will become a small broadcast domain. So this one is a virtual LAN. So here is one single, what they call it, broadcast domain. And this is the group 2 is another domain, another broadcast domain. So one broadcast domain means one collision domain. So the broadcast will happen in many cases if the network is quite large. So the overwhelming of the network resources will become a common thing to happen. That's why virtual LAN is very important to learn and very important to use. Okay, so here, based on this assumption of the LAN limitation, we decided to use virtual LAN to break the large domain into small domains. But after we do this, we will come to another issue. Okay, so the other issue is going to be explained here at the first slide. But before that, we have to see the objectives of our today's class. So upon the completion of this section, you will be able to explain the purpose of virtual LAN routing, and will be able to explain how virtual LAN routing is achieved for layer 2 and layer 3 switches. So we will learn how to configure layer 2 and layer 3 switches, and also how to configure virtual LAN routing. Okay. In the previous class, we said that we are going to break down the large broadcast domain into small broadcast domains using the virtual LANs. So every virtual LAN is a small broadcast domain. So if broadcast happen here, it will not affect the other devices in other virtual LANs, even if they are physically connected to the same switch. So here we have like an isolation, virtual or logical isolation between the virtual LANs. So attempts to limit broadcast domain. So our solution of the last class is to limit the broadcast domain size. So that means we break it down into small broadcast domains. So attempting to limit broadcast domain size through virtual LAN implementation isolates users. So that means when we separate or split our broadcast domain in our LAN into small virtual LANs, so here we will have the logical or the virtual isolation. So computers connected to virtual LAN handle, when they have a broadcast, the other people cannot see that broadcast, cannot be affected by that broadcast because they are in different virtual LAN. But as a result, the computers in virtual LAN 2 cannot communicate with computers in virtual LAN 100 and vice versa. So this group is isolated from the other group. Okay, the question now is how to solve our problem in the last class, how to make the broadcast domain size smaller to reduce the unnecessary traffic and to reduce the unnecessary broadcast and also to efficiently utilize our network resources. How to do that while we keep the connectivity among the small virtual LANs available. So we need to break down broadcasters, but we don't want to isolate users. Okay, let me show the comments that we have in the slides here. So they say the general principle of virtual LAN implementation is to isolate networks as means of minimizing the size of the existing broadcast domain. And I already explained why. However, in doing so, many users are cut off from other users within other virtual LAN domains and require that layer 3 IP communication be established in order for those broadcast domains to re-establish connection through reachable routes. Okay, so from here, we understand that even though these 4 BCs are connected to the same physical switch, the computers from the virtual LAN 200 are not going to be able to communicate with virtual LAN 100 BCs due to the implementation of the virtual LANs. So in order to solve this issue, the issue of isolation, we have to implement a router. We have to implement a router. And that router should be responsible to route the data among the virtual LANs, So instead of what they call it, the default function of the router is to exchange or to allow packets to travel from one network to another, But in this case, the router will be responsible to deliver data from virtual LAN to another. So here, this is a special functionality for the router now. And this special functionality is called virtual LAN routing. Virtual LAN routing is used to solve the problem of users isolation. So the implementation of a layer 3 switch offers an ideal means for supporting virtual LAN routing whilst reducing operating costs. So instead of using router, which is very costly, they advise us to use layer 3 switch to support the virtual LAN routing instead of using physical router to do this function. So this, all of this is only to reduce the cost, because the cost of layer 3 switch is not compared to, cannot be compared to the price of the router, because router is very expensive compared to the switch. So still, we can implement layer 3 switch in order to implement the virtual LAN routing. So one of the constraints of virtual LAN routing is the need for strict IP address management. So in order to do routing, we have to assign IP addresses here. So one IP address from every virtual LAN. If let's say we have 10 virtual LANs, then we have to assign 10 IP addresses for the virtual LAN routing. So this is considered an IP address wasting. Okay, but anyway, it's still a worthy solution because it can help us divide our network using switches to provide virtual LANs in order to reduce the cost of the network implementation. Okay, generally, virtual LAN routing principle is applicable to small-scale networks on which users belongs to different network segments, and IP addresses of users are seldom changed. So if the IP addresses are seldomly changed, then we can rely on the virtual LAN. And also virtual LAN cannot be implemented for huge network or large network. It's suitable for small scale networks. So maybe 100 BC, maybe something like this. But if let's say we have like 1000 BC or 2000 BC, that means we better use the normal networking principles of using switches and routers instead of using virtual LANs. And maybe inside small departments, we can implement virtual LANs to solve the small issues. Okay. In this slide here, we are going to explain the main principle of virtual LAN routing. So virtual LAN frames are routed over a trunk link for port conservation. So here, if let's say this is virtual LAN 3 and here is virtual LAN 2, and then we want to allow host A and host B to communicate, then here we have to implement a router. So this router here, they call it one arm router, or maybe single arm router. Why single arm router or one arm router? Because this router is connected to the switch using only one cable. So this cable is going to be used to take the traffic from virtual LAN 3 to router, then from the router to virtual LAN 2 and vice versa. So every packet that's meant to be sent from virtual LAN 2 to virtual LAN 3 have to travel through this link here. Okay, maybe I better use drawing. So the packet is supposed to go like this, then go inside the router and come back. Its acknowledgement also have to traverse like this. So here we have unnecessary delay. Actually, we will have unnecessary extra delay because the packet is supposed to go like this because they are physically connected to the same switch. And also, if we use ping from host A and host B, the TTL is supposed to be only one node. Am I right? Must be only one node along the path. But in this case, if we use the single arm router, then when the packet is going to be sent from here to the switch, this is one hop, second hop, then third hop, and so on. So here the path becomes 3 hops path. So 3 hops path compared to 1 hop path is longer in terms of delay, and the speed supposed to be slower and so on. And also the other issue is that in here we are going to have a bottleneck. So if let's say we have only 2 computers like now, then this one is going to be normal. So we will see that we don't have that much degradation in performance. But if let's say we have other BC here and other BC here and also other BC there, maybe 6 BCs or maybe 10 BCs or maybe whatever number. So in this case, if all of these BCs wants to communicate from virtual LAN to another, then this link will become fully congested. So if this link is fully congested, then we may lose the connectivity between BCs from different virtual LANs. Okay, and the other thing, even if we don't lose the connectivity among the virtual LANs, we will face a very high level of performance degradation. So the network will become very slow and maybe some applications are not going to be working properly. Okay, so this is a solution, but not the optimal solution. But let us learn how to make this And after that, we see how to make virtual LAN routing without the router by using the layer 3 switch. For this scenario, other disadvantages is that the cost is very high. Why? Because we need to implement a router. And also, in the router, we have very limited number of ports. So normally routers maybe have two ports, 3 ports, or 4 ports. If we want to increase the number of ports, the cost is going to be increased very highly. That's why the cost of implementing virtual LAN routing using single arm router is not a good idea. So we have to avoid, unless we cannot find a layer 3 switch, or maybe we already have a router that has empty ports or something like that, and we don't want to buy layer 3 switch, then maybe we can utilize that existing devices. But if, let's say, we are planning to have a network from the beginning, we better choose or to buy switch layer 3 switches if we are planning to use virtual LAN routing. I hope this is clear. So let me here read for you some comments here that they written. Virtual LAN frames are routed over a trunk link for port conservation. So here, this one is a trunk. This one is access, and this one is access. Or maybe all of them can be hybrid. If you forget about this, you just go and watch the video of the last class of virtual LAN principles that explains how to use the access port and how to use the trunk port, and also how to use the hybrid port and how to configure them. Okay? So after virtual LAN are configured, the hosts in different virtual LANs are unable to directly communicate with each other at layer 2. So layer 2 cannot allow PCs from different virtual LANs to communicate. It's therefore necessary to facilitate the communication through the creation of routes between virtual LANs. So here, because of this isolation, layer 2 will not allow different PCs from different virtual LANs to communicate. Then we have to create routes between these different virtual LANs. So to create routes, we have to have a router. Or maybe we have to have a layer 3 switch. So here, there are generally 2 main methods via which this can be achieved. So to make routes among different virtual LANs, we have 2 ways. We have 2 ways. So the first way is to implement a router connected to the layer 2 switch. To implement a router like this here, one router that's connected to layer 2 switch. If this one is layer 3, then is no point to have this router. I hope this is clear. But if, let's say, this one is layer 2, then this router have to be here. Okay, we have to implement a router, and then the router can be connected using one single link, or maybe 2 links, one for transmission and one for reception. Okay, so actually 1 link or 2 links depends on the empty ports or the available ports in the router. If, let's say, in the router we have two interfaces empty, we can implement 2 links better than 1 link. But if, let's say, we have only 1 empty port at the router, then we have no choice. We have to implement only single link between the router and the layer 2 switch. So in the first scenario, the first solution using the router, virtual LAN communication is then routed through the router before being forwarded to the intended destination. As I mentioned, so traffic will be like this. Then after that will be routed inside the router and go back to the switch to the host B, and vice versa, like this. Okay, so this is the first implication of using the single arm or double arm router. This may be over separate physical links, which leads to port wastage. So this is the first disadvantage. We will waste the ports in our router, which are very limited and very expensive. And extra link utilization, also the link utilization here will be used for unnecessarily, okay? Or via the same physical interface as shown in the example. So if let's say we want to use 2 links between the router and the switch, this will consume our ports, and the cost will be very expensive. And if we want to make it one single arm, then this will become a very tight bottleneck. Okay, the second solution relies on the use of layer 3 switch. So if this one is layer 3 switch, then this one is no needed. Why? Because the routes can be generated here inside the switch, so this host will be able to communicate to the other host directly from the same switch. So the connection speed will become better, delay will become lower, and overhead will become less, and also we will get rid of the unneeded bottleneck in the previous scenario. So in all, the second solution is better than the first solution, but still it depends on what do we have. If let's say we have these equipments in our store, maybe we can take them and use them until the requirements of our users cannot be delivered. So if this scenario cannot deliver the high quality of communication to our customers or to our users, then we have to think about changing the devices or maybe changing the connectivity using layer 3 switch. Here, layer 3 switch that is capable of performing the operation of both the switch and the router in one single device as a more cost-efficient mechanism. So using layer 3 switch is better than buying layer 2 switch together with a router. Okay, I hope this is clear. The idea is very simple actually, but maybe tricky. As I mentioned in the last class, virtual LAN is easy but tricky. That's why we have to carefully study them and carefully configure them, and also we try to understand, not to memorize. Okay. Let us see the virtual LAN features here. So a single trunk supports virtual LAN routes by using sub-interfaces. So this is one feature that we can use. If let's say we have only one empty port at our router, then we have no choice. We have only a space for one link between the router and the switch. Okay, then here, how we are going to assign 2 different IP addresses through the same interface. How we are going to assign 2 different IP addresses, one IP address from every virtual LAN. So in this case, we have 2 virtual LANs. That means we need 2 IP addresses. This IP address belongs to this virtual LAN, and this IP address belongs to this virtual LAN. Okay, so in this case, we have only one physical interface, but also we still can have logical interfaces, multiple logical interfaces. maybe 2, 3, 4. It depends on how many virtual LAN we want to use. If let's say we want to use only 2 virtual LANs, then we have to assign 2 sub-interfaces or logical interfaces to the only one single physical interface that we have in our router. But if let's say we want to implement 5 virtual LANs, that means we have to create 5 sub-interfaces in the same physical interface here. Okay? In order to allow communication over a single trunk interface, it's necessary to logically segment the physical link using sub-interfaces. Each sub-interface represents a logical link for the forwarding of virtual LAN traffic before being routed by the router via other logical sub-interfaces to other virtual LAN destinations. To conclude this, every sub-interface will represent one virtual LAN. So every sub-interface used here in this router will represent only one virtual LAN. So that means every sub-interface must get one IP address from the virtual LAN that it belongs to. Okay, each sub-interface must be assigned an IP address in the same network segment as the virtual LAN that it is created for, as well as this standard 802.1q encapsulation have to be used to allow for virtual LAN association as the traffic is routed between virtual LANs. So in this case, when we want to use virtual LAN routing using physical router, we have to implement the standard of 802.1q encapsulation algorithm. Okay, it's also necessary to configure the type of the Ethernet port of the switch that connects to the router. So the interface of the switch that's connected to the router must be configured as a trunk or as a hybrid. Okay, so we choose which one we want to use, trunk or hybrid, and depends on our selection, we have to configure them properly. So then we have also to allow frames of the associated virtual LANs, virtual LAN 2, virtual LAN 3 in this case, to pass. Then here in this part of the switch that's connected to the router, we have to make it, for example, trunk or hybrid. Then we have to allow virtual LAN 2 and 3 to pass. Okay? If you forget this configuration, please go back to the previous class video, watch it, refresh it in your mind. Then after that, you can come here and understand what I'm talking about. Okay, here we come to the configuration. So configuration of this scenario is divided into 2 slides. So the first slide is going to configure the switch. And the second slide is going to configure the router. Okay, let us start with the switch. So at the switch here, okay, before we go to the configuration, let us read the IP addresses that we have here for the virtual LAN 2 and for the virtual LAN 3. Okay, for virtual LAN 2, we used 192.168.2.1. So the network ID for virtual LAN 2 is 192.168.2.0. The network ID of virtual LAN 3 is 192.168.3.0. Okay? And here, this router is connected through one link to the switch. Okay, let us read these comments first, then after that we come back to the configuration comments. The trunk link between the switch and the router must be established for support of traffic for multiple virtual LANs through the port link type trunk or port link type hybrid. So we have two choices here to use, either trunk or hybrid. As well as the port trunk allow pass virtual LAN 2 and 3 or port hybrid VLAN 2 and 3. So we can use either one. If we decide to use port link type trunk, then we have to use this command, port trunk allow pass virtual LAN 2, 3. If we want to use port link type hybrid, then we have to use this command, port hybrid virtual LAN 2, 3. Okay, so this has been explained in the last class. Once the trunk is established, the virtual LAN sub-interfaces must be implemented to allow the logical forwarding of traffic between VLANs over the trunk link. So let us here come to the switch. Then at first we need to create virtual LAN 2 and virtual LAN 3. As I explained last class, to create multiple virtual LANs, we have this command, virtual LAN space patch and space 2 space 3. That means we told the switch to create virtual LANs in patch. And these virtual LANs are number 2 and number 3. Okay, after this, after we create the virtual LAN batch 2, 3, then we go to the interface G001 that's connected to host A, and we make the port link type as access. Then the port default virtual LAN is 2, okay? Then after that, we go to interface number 2, we put the port link type as access, and also after that, we use the port default virtual LAN 3. We assign the virtual LAN number to the interface 2. After that, we go to interface 3, which is connected to the router. Then we make it as trunk. Port link type trunk, then port trunk allow pass virtual LAN all. We allow all available virtual LANs, or maybe we can say port trunk allow pass virtual LAN 2 space 3. It depends on how you want to make it. Okay, the second step is to configure the router. So the router now has only one physical interface, which is the G001. But here we are going to split it into logical, two logical interfaces, or into two sub interfaces. So the first sub interface is G001.1, and the second sub interface is G001.2. So the sub interface, the first sub interface, we will assign an IP address from the virtual LAN 1. So this one is 192.168.2.1. Here we use 2.254. So this IP address is from the same range of the host A. And the second sub interface have to be assigned an IP address from the virtual LAN range. So here host B is 192.168.3.1, and here 3.254. So this one is going to be accessible from this device. Okay, how to make this? We have to go to the router A, then we go to interface gigabit Ethernet 001.1. So this command will create the sub interface and will take us to the sub interface view. Then after this, when we go to the sub interface view, we have to implement or to enable the standard of the DOT1G algorithm, the encapsulation algorithm. So we have to enable this feature, DOT1G termination, then after that, VID2. Okay, because we want to tell that this sub interface is connected to the virtual LAN number 2. Then after that, we can assign the IP address using the normal IP address command. IP space address space 192.168.2.254 space the subnet mask. After that, we also have to implement or to enable the what they call it ARP broadcast feature. So the ARP broadcast feature will be enabled using this command, ARP space broadcast space enable. If you forget the ARP feature or the functionality of the ARP, please go back to the slide and try to refresh the idea before you continue here. ARP is the address resolution protocol. So this one is to get the IP address from the subnet, from the MAC address, or to get the MAC address from the IP address. So to remind you, we have ARP and RARP, which is the reverse ARP. So one is the opposite of the other. Okay, after we finish this in the sub-interface 1.1, we have to go to the other sub-interface 1.2. Then also we enable the .1Q termination, and we assign it to the virtual LAN number 3. We assign this sub-interface to the virtual LAN number 3. Then we assign an IP address from the virtual LAN number 3. Then after that, we also need to enable the ARP broadcast using this command. After this, we can go and test our ping from host A to host B. Then we can see the configuration. Okay. Okay. Let us now go to implement this scenario first. Then after that, we come back to the slides to finish the other option of implementing virtual LAN routing using layer 3 switches. Okay, let us open our simulator, ENSP simulator. Then after that, we put some devices. So our devices must be one switch, here, 2 PCs, 1 router. Router must be this one. So after this, we click on the white space and we run the simulator. Okay, let us now connect them. So PC1 is connected through Ethernet 1, PC2 is connected to Ethernet 2, then here GE001 is connected to GE00. Okay, so here we try to modify the things here. And remove these captions to make it clear. If let's say this one is wrongly I shut down the simulation. Okay, no worry. This one is our virtual LAN 2, and this is our virtual LAN 1. Okay. Now what we want to do is, I don't know why this router is not running. Oh, it's ready. Because it's ready now. Okay. The first thing we have to do is to assign an IP address 192.168.1.1, for example. Then here we use 2.255.255.255.0. Okay. So here, I forget what is the IP address they use here in this scenario. Okay, oh, they wrongly use the same IP address here and here. This is wrong, totally wrong. But in here, it's already corrected, I think. Okay, we need to correct this as well. So this one need to be also modified to 1, and this one need to be modified to 3.1. Okay. Okay. So this one is 2.1, and the other one is 3.1. 192.168.3.1.255.255.255.0. Okay. So even now, if let's say from BC2, if we want to bring 192.168.2.1, which is the BC number 1, here we will get the message of destination host unreachable. Why unreachable? Because these two IP addresses belongs to different subnetworks. Why? Because the subnet mask is 255.255.255.0. That means in order to be in the same subnet mask, the first 3 octets must be in the same range, must be equal. So 2 is not equal to 3. That means these two IP addresses belongs to different networks. Okay. Let us now go to the switch. So here in the switch, we are going to undo logging. Then we go to system. After that, we go to interface number 1. Interface Ethernet 001. Then what to do here? We have to say port type is, oh, sorry, not port type. This one, the command is like this, port link type, yeah. Port link type access here, then port default is VLAN 2. This command, port default VLAN 2. The VLAN does not exist. Oh, because we forgot to create the virtual LAN. Sorry about it. So let us quit. At first, we have to create VLAN patch 2 and 3. Okay. This operation may take a few seconds. Done. So now we have 2 virtual LANs. If let's say we display VLAN, we can see that we created 2 and 3 because number 1 is the default. So all ports in the switch belongs to virtual LAN number 1, as you can see here. Okay. Here, after we create the virtual LANs, we have to go to interface 001 that's connected to BC1. Then after that, we have to use the port command link type access. Then after that, port default is VLAN 2. We assign this interface to virtual LAN 2. Then after that, what else we have to do? The other thing that we have to do is to go to the, yeah, for the first port is that's enough. Then here we have to go to the next interface, which is number 2. Then we use the same command, port link type access, then port default is virtual LAN 3. Then after that, we go to interface gigabit Ethernet. First interface gigabit Ethernet 001. Okay, then after this, we have to do link type trunk. And after that, we use port default. Link type, we already changed the link type. And here, link type is trunk. That means we don't have to assign it to the, what they call it, to like here, normal access port need to be assigned to as a to the virtual LAN using the port default command. But for the trunk, we, instead of that, we need to use port trunk allow pass. So here, port trunk allow pass, either to allow 2 and 3, or maybe allow all virtual LANs. Sorry, before this we have VLAN all. Okay, so here if we want to see display VLAN, then we can see here that interface G001 or G00 is, which one I used? I forgot which one I used. Oh, I configured the this one, sorry, because in the switch we don't have 000. Okay, so interface in the switch G001 is belongs to the virtual LAN number 1, which is the default. And at the same time, here, this one is untagged, but here it's a member of virtual LAN 2, but as tagged member. And also it's a tagged member of virtual LAN number 3. That means virtual LAN 2 and virtual LAN 3 are allowed to be traveling over the GE001 interface. All of the virtual LANs are enabled, statistics are disabled. Don't worry about this. For this now, we have already finished the switch configuration. Now we need to go to the second step. So the second step here is going to, what will happen here is going to configure or to create the sub interfaces, and after that we have to configure them. So let us go to the switch first, to the router, and at first we need to undo terminal logging. After that, go to the system view, and here we need to create, we are using the GE000. So we need to use interface G Ethernet 000.1. This is the first sub interface. Okay, as you can see here, we are already in the sub interface 000.1. So here, the first thing we do, we need to enable the .1Q termination. I don't know why. VID2. Oh shit. Yeah, I did a mistake. I used the dot here because the standard is .1G, but dot here is written as DOT. So here we use .1Q, then termination VLAN, VID2. So this interface must be assigned to the virtual LAN number 2. Now we need to assign an IP address of 192.168 to, for example, 200. Oh, we forget to assign, to mention the subnet mask. After that, we need to enable the ARP broadcast enable. Then now we need to go to the other interface, sub interface 000.2. And now we do the same thing, but with different IP address and different, what they call it, virtual LAN. So this sub interface have to be assigned to the virtual LAN ID number 3. And after that, we have to also enable the ARP broadcast. And also we have to assign an IP address. So here 3224. Okay, here we are, and everything now is ready. Everything is ready. So if we go to BC number 1, this is BC number 1, and this is BC number 2. If we go here and we check the connectivity using the ping command, okay, I want you to understand what is going on. So here we assign it to 1, and here is 3.1. So if we use the command, this command, to ping 192.168 to, sorry, this one is 2.1. So we have to ping 3.1. So here destination is unreachable. Destination is unreachable. Why unreachable? Because here we want to communicate from one subnet network to another subnetwork. In this case, we have to use the gateway. So our gateway in this network is 192.168 to 200, which is the interface assigned, the IP address assigned to the sub interface, which belongs to virtual LAN 2. Okay, so apply here, then command. We also will get the same result, but now the result is request timeout. Why request timeout? Because the first time destination is unreachable, because the BC knows that this IP addresses belongs to different subnetwork. That's why the ping request is not sent. Ping request is not sent to the destination. But in the second case, after we define the gateway, here the request, the ping request is already sent, but the acknowledgement is not received. You know why acknowledgement is not received? Because the acknowledgement have to be sent from the other PC to the sender, to BC number 1, but the way is not defined. That's why we have also to define the gateway in the other BC. So here the gateway of this BC is the other sub interface that belongs to the same virtual network. Okay, let us now ping. So now everything is fine. Okay, so as you can see here, delay is 78 milliseconds. It's quite high because this one is considered the local network, but because we inserted the router, then we can see that the time is increased. Also from here, we can Bing 192.168.2.1. Why? Because we already configured the gateway and everything is running well. Okay, to confirm that this traffic is going from BC1 to switch 1, then after that it will be routed inside the AR1 router, then back to switch 1, after that to the destination. Let us go here to router 1 and let us disable, for example, this interface. So here, sorry. To disable an interface, yes, we have to use a shutdown command. Shutdown command here. So this interface is shut it down. The sub interface is shut it down. If we go now and Bing from here to here, as you can see, now we cannot Bing. Why? Because the connection is lost. From here, the connection is lost. But what if we return? Let us use this Bing command -t. I'm not sure whether it's working or not. -t, it's supposed to continue until we finish. Until we finish it manually. Not like this one 4 or 5 times, then stop. Okay, now it's continuously working, continuously doing Bing. Let us now go to the router. As you can see here, permanently, you can see that this one is request timeout, but once we undo shutdown on this interface, we can see that the Bing is going back to normal automatically. What does it mean? This means the traffic is actually using this single arm that's connecting the router and the switch. So the traffic, as I mentioned, is going this way from here to here. Then after that, it will be routed here and go back here. Then this is the Bing request, and the reply must be go back from here to here, then will be routed to back to the source. So now here, this will create a bottleneck for us and the performance will be degraded. Okay, that's all about the first option. So now let us continue with the slides. And after that, we go back to the configuration. Okay. Here, virtual LAN configuration. This one is already done. Let us see the conclusion of the configuration. So following the configuration of virtual LAN routing between virtual LAN 2 and virtual LAN 3, the Bing application can be used to verify reachability. The example demonstrates how host A with this IP address in virtual LAN 2 is able to reach host B using this IP address in virtual LAN 3. The TTL reflects that the packet has traversed the router to reach the destination in virtual LAN 2. How TTL is used? Actually, the default value of the TTL is 128. And when the packet travels through one hop, then this number is going to be reduced by 1. It will be reduced by 1. So here that means the path has only one hop. Okay, let us now go to the second scenario. In the second scenario here, we are going to remove the router and we are going to use the layer 3 switch. I'm not going to implement all of this. This one is also wrong. So please modify your slides. This one is Huawei mistakes. This one is also 1, and this one is 2. Actually, we are using the Huawei slides without any modification because we want you to be related to the real market, to the real industry. That's why we use them as they are, but we have to make sure that there is no mistakes. So from time to time, we may fix some bugs. Okay, the implementation of layer 3 switch brings about benefits to the process of virtual LAN routing that are not possible through the use of a router. So this layer 3 switch will bring a lot of advantages. So the first advantage is what they call it virtual LAN interface. Virtual LAN interface, VLAN IF. VLAN IF are used by each VLAN as a route gateway, As you can see here, this VLAN interface actually is a logical interfaces, like the loopback, similar to the loopback. So they are not physical interfaces, but this one have to be created. Depends on how many virtual LANs we have. In this case, we have 2 virtual LANs, then we have to use VLAN interface for every virtual LAN. So we can see we have 2. The first one is for VLAN 2, the second one is for VLAN 3. One of those features is the ability to forward VLAN traffic with very little delay due to support of what is known as line speed forwarding as a result of bottom layer ASIC chip that allows traffic to be forwarded based on hardware rather than software. In the previous solution, we relied on the software and the hardware. That's why we faced quite high delay. But in this case, we are going to rely only on physical hardware. Definitely by using some logical configuration like this virtual interface. Along with this is the fact that a single device is used within no trunk link that may otherwise face congestion under heavy traffic loads. So we get rid here of the trunk link. Trunk link actually will do tagging, untagging, and that requires a lot of process and the delay will increase. And also the single arm between the switch and the router will be the bottleneck and will create a lot of congestion. So virtual LAN routing when using a layer 3 switch relies on the implementation of virtual LAN interfaces. If multiple users on a network belong to different virtual LANs, each virtual LAN requires one virtual LAN interface that acts as the virtual LAN gateway. So this one, this virtual LAN interface, the IP address assigned to the virtual LAN interface is going to be used as the gateway for this network. And the second one is going to be used as a gateway for the second virtual LAN. If a large number of virtual LANs exist, however, this can tally up to a large number of IP addresses being required to support each virtual LAN interface, as well as the hosts that are part of the virtual LAN with which the virtual LAN is associated. So if let's say we have a big number of virtual LANs, then we have to have many virtual LAN interfaces to be configured, and every virtual LAN interface requires one IP address. So this is considered as a waste of IP addresses. The last thing here, through the virtual LAN interface routing between different virtual LANs can be supported. Okay, let us go and check here. what is the difference between the configuration of this scenario and the configuration of the previous scenario? So here, what they have done here, they created the virtual LAN using the batch command. And after that, they went to the first interface. They use the link type access. They assign it to the virtual LAN number 2. Then after that, they gone to the other interface. They use the access also, and they assign it to the virtual LAN number 3. Okay, so this configuration here is exactly similar to the previous scenario. But the only thing that we have different than the previous scenario is that in this switch, we have to configure some virtual interfaces instead of configuring the router. So what I'm going to do here, actually, I'm going to keep this scenario, but I'm going to delete the router here. So links will be deleted, and also configuration of this interface will has no point actually to be there. It's not going to be active. So here inside the switch, what we want to do is only to create what they call it interface. Instead of using the trunk interface, here we use the logical interface, which is the VLAN IF. VLAN IF, we create VLAN IF number 2. Then here we assign for this interface, sorry, this one, I think, yeah, I thought that I did mistake here, because this one has no space, but this is correct. Okay. Here IP address have to be assigned. So IP address here for the interface for the virtual LAN number 2 must be 192.168.200, exactly similar to the previous configuration that we used for the router. So now virtual LAN interface number 2 is already assigned the IP address 192.168.200 space 24. Okay, let us now go to interface VLAN IF3. VLAN IF3. Then here we have to assign an IP address, but different IP address with the subnet mask. Okay, that's all. That's all we have to do. So here, if we open the BC2 and BC1 here, because here we have already configured the gateway, and we are still using the same IP addresses with the virtual LAN interfaces. So that means easily we could get reply. You see, easily. This one is stuck, I think. So I need to repeat the command here. Then you can see both of them are working. If you remember, last time the delay was varying from 62 to 94, and here in this case the delay is lower than the previous case. Why? Because we have reduced the complexity of the connection. Okay, we repeat again. Don't know why it stopped. This is the problems of using the simulator, actually. Yeah. And maybe this is due to the fact that we did not delete the what they call it. The last time we used interface gigabit Ethernet 001 in the switch. and we make the port undo port type trunk. What happened here? Oh, this is correct, but I don't know why it doesn't work. Here, if you go back here, you can see that we already used the port link type trunk. But before that, we have to what to do? We have to, because the trunk is already enabled and it allows traffic from different virtual LANs to be passed. So here also we have to, maybe we have to put trunk allow pass. We undo this command, it doesn't work. It works, but we forget this. VLAN all, yeah, works. Then after that, we undo this. I don't know why it doesn't work. Anyway, okay, here, if we repeat now, it works. It works back to normal. Okay. So as you can see here, the delay is less than the delay when we use the router. And also the configuration is very simple compared to the scenario of using a single arm router. That's all about the configuration of the virtual LAN routing input scenarios. Okay, we go now to the last. We still have some things to be explained here. In this slide, actually, they have some notes. Let us go through these notes. Maybe we forget something to mention about or something like that. So configuration of virtual LAN routing on a switch operating at layer 3 requires that the virtual LANs be initially created and the interfaces be assigned to those respective virtual LANs. I already explained this. So here, the interface have to be assigned, exactly similar to the previous scenario. The configuration follows the principles of configuration of virtual LANs covered as part of the virtual LAN principles, exactly similar to the configuration that we did even last class. This involves defining the port link type for each port and the BVID. BVID here is this command. So we use the port default virtual LAN and we follow by the virtual LAN number. So the BVID have to be assigned to the port. After that, here in the configuration of the virtual LAN interfaces, configuration of virtual LAN routing is implemented by creating virtual LAN interfaces that are to operate as gateway interfaces for each virtual LAN within the layer 3 switch. So here, these virtual interfaces, as I mentioned, the first one have to be used as a gateway with this PC, and the second one is going to be used as a gateway for the PCB, for the host B. Okay. Entering the virtual LAN interface view is achieved via the interface VLAN followed by the VLAN ID command, where the VLAN ID refers to the associated virtual LAN. The IP address of the interface should be in the same network segment as the hosts. So here, this IP address is supposed to be from the same group. Supposed to be from the same group of the virtual LAN 2. And this IP address is supposed to be from the same group of the virtual LAN tree. This IP address shall represent the gateway for the hosts and support the inter-VLAN communications. Okay, finish. Now we go to the summary slide. In the summary slide, we have two questions. The first question is, what is the purpose of the .1q termination VID command? So as you can see, the answer is below in the comments here. The .1q termination VID virtual LAN ID command is used to perform two specific functions. The first function, where a port receives a virtual LAN packet, it will initially remove the virtual LAN tag from the frame and forward this packet via layer 3 routing. For packets being sent out, the port adds a tag. So from layer 2 to layer 3, this .1q will remove the tag from the packet. But when the packet is processed in layer 3 and the route is already found, then the packet should be sent from layer 3 to layer 2 again. Then the tag have to be inserted. After that, the packet will be forwarded. So this is all of the functions that we achieve using the .1q standard. Okay, the second question, what is required to be configured on the switch to allow virtual LAN traffic to be forwarded to the configured sub-interfaces? So here the answer is that, as you can see here, the switch must be configured to allow frames carried over the switch to router medium. So the switch must allow the traffic from all virtual LANs to be traversing the link between the switch and the router. So the command is to use the port trunk allow pass virtual LAN. Then we use all, or maybe we list the number of virtual LANs that we need to allow them. Depends on the type of the port that we use. If trunk, then we have to use the proper command for the trunk. If we use the hybrid, then we have to use the proper command for the hybrid. That's all about the virtual LAN routing. And inshallah, I hope that everything is clear. If you have any question or maybe anything is unclear, please WhatsApp me, please send me through the email or whatever, and I will answer you directly. And please watch the video carefully and try to follow every step. Try to follow every step. If the thing works using your simulator, that's fine. If it doesn't work, please let me know. Thank you for following me, and see you inshallah next class. Thank you very much.